Dear students, in this video, you are going to see permutation group. Before that, first we have to look at what is permutation. Permutation is nothing but arrangement. Okay, what is arrangement? See, let's do a permutation problem here. How many different arrangements are there for three books on a shelf? Okay, books A, B, and C can be arranged in these groups. Okay. Suppose we have three books named as A, B, and C. Okay, just to imagine that we have three books on a shelf in LRC. Okay, how to arrange these three books in a straight line? You see, we can arrange, see, book A, then book B, then book C, or you change here the arrangement, book A, book C, book B, and then you can change. Okay, in how many different ways we can arrange these three books A, B, and C? See, the total number of ways are 6. Total number of ways are 6. See, this is 1, 2, 3, 4, 5, 6. Okay, now if you have three elements or three books or any three objects, you can arrange that three in 6 different ways. Okay, that is here. How to find this 6? See here, how many books we have? 3 books. How many books we have? 3 books. So n is equal to 3. Okay, so now what is n factorial? That is 3 factorial here, because n is equal to 3. How to calculate 3 factorial? You multiply 3, multiply 2, multiply 1. So 3 multiply 2 multiply 1, that's equal to 6. So that here we are getting 6 different arrangements. That is the permutation. Okay, now you see, what is permutation on a set? You see, a permutation on a set X is a bijection sigma. This is called a permutation on the set X into X. We denote the set of all permutations on X by this notation, permutation of X. Okay, this is the formal definition. Now here we see few examples on permutation and how to calculate the length of the cycle, then how to write the permutation form into the cycle form into the permutation form. Okay, now you see here we consider a set X. Okay, 1, 2, 3, 4. How many elements we have? We have 4 elements. So how many total number of different permutations we can form? We can form 4 factorial. Okay, 24 ways we can form. Okay, now here we take one permutation that is called sigma. Okay, we have one permutation sigma that's equal to, see, in the first row, see, you have to write what we have in the set. Just you write 1, 2, 3, 4. Okay, in all permutations, suppose I have 7 elements, then you write 7 elements. Now here we have 4 elements, so you write 4 elements. Then here what is given? See, permutation sigma is equal to 1, 2, 3, 4 is nothing but the number of elements appears in the set. Then 3, 4, 2, 1 is here the arrangement. Okay, now this is called sigma, is a permutation. Okay, which means what? See, sigma 1 is equal to 3 means this 1 goes to 3, then 2 goes to 4. See, that's why I put arrow. Okay, or we can say that, see, 1 assigned to 3, 2 assigned to 4, 3 assigned to 2, 4 assigned to 1, like that. That's why they are writing sigma 1 is equal to 3, which means here this element, the number 1, the element 1 is assigned to 3, like that. In a similar way, we can say sigma 4 is equal to 1. Okay, now here we are going to calculate the cycle length and how to write the cycle form. Okay, now you see here in the given permutation, 1 goes to 3, then 3 goes to 2, then 2 goes to 4, then 4 goes to 1, again 1 goes to 3. Okay, so now, which means, see, you start from 1 and then you write what we have discussed, then until 1 you write, then cycle starts 1 which ends in 1. Okay, now that's why we can write cycle form of the permutation, that's equal to 1 to 3, 3 to 2 to to 4. Okay, again see here 4 goes to 1. That is the starting point, so no need to mention here. Okay, so now this is called the cycle form. And how to calculate the length? Now you see all the four elements are assigned into the another element. So 1 to 3, 3 to 2, 2 to 4, 4 to 1. So the length is 4. Okay, you calculate this 4. So length is 4. Okay, now we will see another example. Let here sigma is missing. So now here, what is this? This is sigma. Okay, let sigma is equal to this permutation. Here, what is the set X? From this you can understand 1, 2, 3, 4, 5. So 5 elements in a set. Okay, this is the given permutation sigma. Okay, now here you see 1 goes to 3 and then 3 goes to 1 and cycle is over. Say again 1 goes to 3, 3 goes to 1, we can say, which means this is called 2 cycle. The length is 2 because these two elements only or means arranging themselves. So 1 to 3, 3 to 1, 1 to 3, 3 to 1, like that. So it is 2 cycles, or we can say transposition. What is the another name of 2 cycle? That is transposition. Okay, see next 2 goes to 5, then 5 goes to 4, then 4 goes to 2, then 2 goes to 5. Okay, so these 3 elements having the cycle. Okay, among these 3 we have one cycle, we have one rotation. Okay, so that we can say 2, 5, 4 is another cycle having length 3. Okay, so what we are writing here, we are writing the permutation into the cycle form. Now you see here sigma is equal to, how I can write the cycle form of this permutation. This is permutation form, this is cycle form. So now you write the first cycle, that is 1, 3. Second cycle 2, 5, 4. Okay, this is the cycle form. Now you see another question. Let sigma is equal to 1, 2, 3, 4, 5. Then 1, 5, 4, 3, 2. Okay, this is the permutation sigma. Okay, now how we can write this in cycle form? Now you see 1 here goes to 1. Okay, there is no difference. See, we remark that in this cycle form 1 is not mentioned, because which means that sigma 1 is 1. See, 1 is assigned itself. Okay, so now here, so when you write the cycle form, see, if the number assigned into the same number, no need to mention here, no need to write here 1, no need to write here 1 here or here, no need to write. Why? Because if the same number is assigned self, so no need to write. Okay, so now 2 goes to 5, 5 goes to 2, 2 goes to 5, 5 goes to, which means these two numbers having the cycle, which means transposition, or we can say 2 cycle. So that I am writing 2, 5. Similarly, you see 3 goes to 4, 4 goes to 3, 3 goes to 4, 4 goes to 3. So this is also 2 cycle. Okay, no other numbers coming in this cycle. Okay, so I can write, see, I can write this permutation like this. This is 1 cycle, means 2 cycle. This is another 2 cycle. Okay, no need to mention 1. Why? Because here 1 is assigned into 1 again. Okay, so now this is another example how to write the permutation form into the cycle form. Okay, this is permutation form, how to write cycle form. Okay, this is cycle form. Now we see here, what is composition? Already you studied in pure mathematics. What is composition? See, sigma 1 and sigma 2 are 2 permutations in Sn. Then how to find sigma 2, sigma 1, which means sigma 2 composite sigma 1. Okay, first you have to see, we have to apply sigma 1 first, then sigma 2 second. Okay, to find sigma 2, sigma 1. Okay, sigma 2, sigma 1 is nothing but sigma 2 composite sigma 1. Okay, now you see here, see, cycle form is given. See, this is sigma 1, this is sigma 2. This is cycle form of the permutation. This is cycle form of the permutation. Okay, how to write this into the permutation form? Now you see here, see, permutations on S6. S6 means you have tried 1, 2, 3, 4, 5, 6 in the first row. Now you see sigma 1 is 1, 2, 5. You see 1, 2, 5. Total numbers 1, 2, 3, 4, 5, 6. See here, in the cycle we have 1, 2, 5, which means 3. What about 3? What about 4? What about 6? Which means no assignment. These elements assigning itself. You see here? So that here, for 3, I am writing 3. Okay. For 4, I am writing 4. For 6, I am writing 6. Yes. It assigns itself. Okay. But you see the cycle, 1 goes to 2, 2 goes to 5, 5 goes to 1. So that I am writing 1 goes to 2. Then 2 goes to 5. So that I am writing 2 goes to 5. Then I am writing 5 goes to 1. So that I am writing 5 goes to 1. You see here, for 3, 4, 6, no changes. But for 1, 2, 5, there are changes according to this cycle. Similarly, you can write this. Here, 3 and 6 having means 2 cycle. See, 3 and 6 is 2 cycle. That's why 3, 6, 6, 3. But here, 1, 2, 4, 5, no changes. Okay. Okay. Now, what we are going to do? We are going to calculate sigma to sigma 1. That is sigma to composite sigma 1. We can say. Okay. Which means what? First you apply sigma 1, then you apply sigma 2. Okay. See, sigma 1. Sigma 1 means what? See, this is the starting position. Okay. 1, 2, 3, 4, 5, 6, which is appear in the set. Okay. Now, what is sigma 1? You write this 2, 5, 3, 4, 1, 6. 2, 5, 3, 4, 1, 6. Then what is in sigma 2? You write here. See, what is this? 2, 5, 6, 4, 1, 3. But this is how we write here. 2, 5, 6, 4, 1, 3. Very simple. You see here, in sigma 1, 1 goes to 2. Then you see this 2 in sigma 2. Where it's going? 2 goes to 2. That's why I'm writing 2. You check one more. See, 2 goes to 5. This 5 goes to 5. So you write 5. Understand? In a similar way you can write. Then you write the answer. That is this is the answer. Okay. Sigma to sigma 1, which means you write all the elements which appears in the set. Then you write this. Okay. So this is the answer. This is the composition. Sigma to composite sigma 1. This is the answer. This is the permutation form. This is called permutation form. How to change into the cycle form? Already you know that. You see 1, 2, 5. We have 1, 3 cycle and then 3, 6. But here 4 assigned itself. So no need to mention here. Okay. This is one way. Another way, how to find this sigma to sigma 1. See, this method I prefer. Okay. Sigma to sigma 1. How to find sigma to sigma 1? Okay. Now, sigma 2 you write from the question. Sigma 2. Yes, this is sigma 2. This is sigma 2. From the question you write. Okay. What is sigma 1? From the question you write. Okay. First you do this part, then you do this part. Okay. That is given here. See, first we apply sigma 1, then sigma 2. Okay. So now what we have to do here, which means you start from the second, means you start from the second permutation. Okay. Sigma to sigma 1 means you start from this side. Start from right side. Okay. You start from here. Okay. Now here 1 goes to 2. You see here 2 goes to 2. That's why I write the answer directly 2. Okay. Now 2 goes to 5. Then 5 goes to 5. I write this answer. Okay. Then 3 goes to 3. Then here 3 goes to 6. So that I write here 6. Okay. Then 4 goes to 4. Here 4 goes to 4. So write 4. See, 5 goes to 1. 1 goes to 1. So write 1. Then 6 goes to 6. Then 6 goes to 3. So I write 3. Okay. I'm telling the second row only. Okay. First row always you write all the elements which appears in the set. Okay. Is 6. So you write the 6 elements here. You write the 6 elements. Okay. Then how to write this second row? What I explained, similar way you write. Okay. After that, you write the cycle form of the permutation. That is your answer. Okay. Now, we will see the continuation of this lecture in the next video. Thank you.